I think I got it.
I got it.
Wow, so you guys think you've got it. Got it. All right, here we go. So this is NECAP2007, number 16, I think. And as I said, 0.9 out of 1 is the score that our school got. 0.8 out of 1 is what the state got on average. So it says Zach has $60 to spend on a fish tank, supplies, and some fish. Hopefully he gets at least some fish. That would be disappointing if like he bought everything and then just like, eh. The fish tank and supplies cost $29.50, flat price right there. And each fish, each is a key word. That means this is changing. The overall cost will change depending on the number of fish. Costs $2.70. What is the maximum number of fish that Zach can buy? So, do we have a guess right now? We can throw some guesses out.
11.
11.
Yeah, I said 11 too.
12.
Oh, I've got an 11.
It rounds to 11.6.
Well, we'll have to consider that. Okay, so I hear some 11s and 12s. Let's see. Let's let F equal the number of fish. I'm going to give a variable here. I figured F is a good name for it. You don't have to use F. And let's see. I know at most he has $60 to spend. So the total price he spends would have to be less than or equal to 60. But we'll just say equal for now. Eventually we'll do some inequalities, but don't fret. And let's see, what prices can be up to that? Well, the $29.50. Is that going to change based off of our variable F? Right, I'm not going to multiply that by F or anything because $29.50 is the same no matter how many fish you buy, unless somehow the number of fish you buy fills the tank to capacity and there's no room for water or more fish. I'm assuming you'd have to buy an additional tank if that was the case. So that's going to be a part of it. And then it's $2.70 per fish. So how could I represent that mathematically?
270, like X or something?
Yeah, 2.7 times the number of fish, right? So F or X, if you chose X, that's fine. And yeah, so it's F is the number of fish. 2.7 times the number of fish would represent what? What would this whole term represent? Is that still in numbers of fish? The cost of all of the fish together, right? Yeah. Okay, so I think we've got an equation we can work with. Now we can solve this. So even though these are scary decimals, what do you think you do to solve? What would we get rid of first, the 2.7 or the 29.50?
29.50.
I think that's the right move. And I can't just like subtract it from one side. I got to subtract it from both sides. So I've got 2.7F equals, is that 30.50?
I got 31.50. It's
I think it's 30.50, right? Because if I add 50 cents, that would bring this to 30, right? And then I'd have 30 left over. So yeah, it's 30.50. But I see how it would be easy to do that. 60 minus 29 would be 31. Yeah. And then what would I want to do? Well, I don't want to do this math, but what would I have to do to solve for F?
You would have to divide by 2.
Right, because 2.7 is being multiplied by F, so we'll divide both sides by it, and that's not math that I want to do. Ugh.
Equals 11.
And F equals, like straight up?
Yep.
That goes in evenly?
No. It's like 11 points.
Yeah, you can't buy another fish. You can't have 12 because you're on a
You can't round up.
Yeah, you can't round fish.
You can't just like slice a point.
Yeah.
Well, I mean, depending. What if he's buying these fish to like feed his other fish? And then like he's like, I kind of do want that 0.296 of a fish. Like, can I buy this and like feed it to my other one? Yeah. But assuming he's using these as pets, I'd say that the maximum number of fish, whole number, would be 11. Yeah. And so yeah, so Zach can buy 11 pescado. Why would you want 11 fish? Exactly. That's the whole premise of this. Why would anyone buy any fish ever that they're not just going to eat, like salmon or something?
I had tuna. The real tuna.
Yeah, I ate some last night myself. But anyways, so there's some kneecap questioning. How'd we do? Or decimals scare us off?
I done it.
Yeah.
Okay, that's pretty good. All right, good stuff.